This is HL paper 2 question 5 and SL paper 2 question number 3. It's all about a simple pendulum, and the physics that it asks about within it is simple harmonic motion and circular motion. And a lot of you missed that out. Clearly, when we're dealing with simple harmonic motion with a pendulum, it's actually an arc of a circle. So the physics of circular motion applies as well. On the sketch graph above, label with the letter A a point at which the acceleration of the pendulum bob is a maximum. Well, when we're at a maximum amplitude, here or here, is when the restoring force acting to return it to the equilibrium position is the largest. So that's where our acceleration is maximum. On the graph, that's at maximum displacement. So here, here, or here. Part 2 then says the maximum velocity, and that's as it passes through the equilibrium position, so where displacement is 0. It then says explain why the magnitude of the tension in the string at the midpoint of the oscillation is greater than the weight of the pendulum bob. Now this, you really had to get to the idea that because the pendulum is accelerating towards the center of this circle, that there is centripetal acceleration and therefore centripetal force, which will add to the weight of the string in order to get a resultant force. So yeah, pendulum is accelerating upwards towards the center of the circle, therefore F increases, which adds to the tension already caused by the weight. Over the page, there's a question that asks, show that question that says the speed of the pendulum bob at the midpoint of the oscillation is 0.7. We've got a change in the height of the pendulum here. It's being dropped from 25 millimeters above its equilibrium height. So you need to deal with this in terms of conservation of energy. Potential energy is becoming kinetic energy, so we can let mg delta h equal a half mv squared. When you rearrange that for v, you get 0.7004, and you should always show more detail than is given in the initial question for show that questions. Next part says the mass of the pendulum bob is 0.057. The center of the pendulum bob is 0.8 meters below the support. Again, this is now dealing with it as if it's a circular motion. So we know that the resultant force between the tension and the weight will cause it to accelerate in its circular path. So that is equal to our mv squared over r. We know the mass, we know the velocity, and we know the radius of its circle, so we can calculate the resultant force at that point. That's going to be upwards in this direction, and the tension therefore must be equal to the weight plus this resultant force. So we can add mg to our 0.0349 to get 0.59 newtons.